at this question in principles of hydrogeology. Um, so we are looking at the hydraulic conductivity of an aquifer. So let's take this example. So an aquifer has three different formation. Formation E. So let's put it down. So we have three different formation. Jesus. Yeah, yeah, no, it's all right. So we have three different layers. Let me change the color. We have three different layers. So I'm drawing this to identify the layer. So we have layer A, layer B, and layer C. Now layer A has a thickness of what, 22 centimeters, and it has a hydraulic conductivity, that is the K, is equal to 17.0 centimeters per D. Then layer B has a thickness of 3.5 centimeters and a hydraulic conductivity of 99 centimeters per D. Then layer C has a thickness of 26 centimeters. It has a hydraulic conductivity of 22 centimeters per day. Now they said assuming each formation is homogeneous and isotropic. So in that case, if so if the formation is homogeneous and isotropic, it means that the K vertical for A is also equal to the K horizontal for A. And the K vertical for B is equal to the K horizontal for B. And the K vertical for C is equal to the K horizontal for C. So the vertical is the vertical hydraulic gradient, hydraulic conductivity, and the H is the horizontal hydraulic conductivity. Right. So the question is asking us to compute the average. So the average horizontal and vertical conductivity. So let me write it here. So the average is, so K H average is given by the formula, the sum of what? K H M B M over B, where we start from M to N, and M starts from what? 1, right? Okay. So this is the formula. Let's define the parameters. KHM is individual horizontal hydraulic conductivity. Then the BM is the individual thickness, layer thickness. And the B is the total thickness. Total thickness of the aquifer is individual thickness. Individual thickness. So in that case, we have everything here, so we can go ahead and compute. So our KH average is equal to, so I take the thickness multiplied by the hydraulic conductivity. So that is going to be 22 times 70. That will be the first one, plus the second layer is what? 3.5 by what? 99, plus the third layer, which is what? 26 by what? 22, divided by the total thickness. So you add the thickness of each layer, which is what? 22 plus 3.5 plus what? 26, right? So in that case, we can go ahead and find out. So we do the computation. So when the computation is done right, you're going to get your horizontal and the average horizontal hydraulic conductivity to be 25.0 0.0971 centimeters per day, right? So if we take the second side, which is the second side, which they are asking us, so let's call this A, let's look at B, where they are asking us to find the vertical. So the vertical, the formula is given by, sorry, so the vertical, the average vertical hydraulic conductivity is given by that one to the sum from m equal to 1 to n, and we have what? B, the total thickness over what? The individual thickness over the individual vertical hydraulic what? Conductivity. So this is the formula. Now, because initially we said the formations are homogeneous and isotropic, it means that their horizontal hydraulic conductivity is the same as their vertical hydraulic conductivity. So in that case, we are going to use the same um, the same information. And so the total thickness, which is 22 plus 3.5 plus 26 all over. Then the individual thickness, which is 22 divided by its corresponding hydraulic conductivity, the vertical. So plus 3.5 over 99 plus 26 over 22. And so in this case, the vertical, average vertical hydraulic conductivity is going to give us what? It's going to give us 20.5017, sorry, 507.5074 centimeters per day. And that will be the end of this question. So I would advise that you go through it and compute it yourself to verify if our final answer matches with what you have. See you in the next video. Bye.